Well, welcome everyone to the ECG approach lecture series and the module on heart rate. So if you've been with us through the last few talks on electrocardiography, you're finally going to say, thank goodness we are into something much more applicable and clinical. If you're just joining us, well, welcome. So at this point, we're really talking about the approach to the electrocardiogram, which I think everyone should have a standardized approach. And certainly a very reasonable one is what you see here with a look at rate, rhythm, intervals, axis, hypertrophy, which we're not really going to talk much about, as I mentioned, because it just doesn't change a lot in the transport environment. And then to look for bundle branch blocks, ischemia, and then pattern recognition for a bunch of the ECGs we need to know. So today we're really going to talk about heart rate. So just to orient us briefly, I think you're all familiar with this. This is basically some ECG paper, and you'll recognize that ECG paper has basically these tiny little blocks that are roughly a millimeter in size, and in each of those papers, they're divided up into these larger blocks of 5 millimeters. So tiny little blocks of 1 millimeter, and then the bigger blocks that are 5 millimeters in size. And realistically, I have to say that when it comes to figuring out the heart rate on an ECG, most of us use two things. And the first one is that the ECG actually calculates a heart rate for you, and the ECG machines actually do a really wonderful job at this. So that's usually the first thing I look at, and that's usually almost good enough for just about anyone. Having said that, there is certainly this very rapid way to have a peek at heart rate, and I'll use it just to eyeball things and make sure that the readout on the ECG is actually reasonably accurate. And this just takes a little memorization, but if you take each of those 5 little block squares, or one big square, and you just count them down, how many big squares. So if you have one big square between your QRS complexes, you're running at 300 beats a minute. If it's 2 squares, it's 150 beats a minute. 3 squares is 100. 4 squares is 75. 5 squares is 60. And 6 squares is 50. And then as you go below that, you enter the 40s and the like, which at that point I'm okay with. So it's really just a quick way to eyeball what your ventricular rate is. And between what the ECG prints out and a quick eyeball of this, that's about all I actually ever use. So at this point, if you're like, that's great, that's all I need to know, feel free to go on to the next lesson. Having said that, if you're one of those guys with calipers and a ruler and you're like, I want to know this from first principle, I'm happy to walk you through it, and we're going to start that here on the next part of this talk. So if you really want to work this out from first principles, you have to understand right off the bat how fast that ECG paper runs off the machine. Now, nowadays with modern ECGs, that paper doesn't just scroll off the machine. I think we've all seen it. The ECG tech or yourself, you capture the picture with your machine and you press print and it prints it off. But in the old days, that paper used to scroll off on a roll, and it used to come off at 25 millimeters per second. So if it's 25 millimeters per second, then each one of those 1 millimeter boxes is worth 0.04 seconds. And of course, each one of those big boxes, which are 5 of those, is 0.2 seconds. So knowing that, why don't we calculate what the rate is between this on this cardiogram with these two QRSs? So the first thing to do is to measure the distances between the QRS complexes. And in this case, if you measure that out, it's 21 millimeters, or 21 of those little boxes. And remember that each one of those boxes is 0.04 seconds. So 0.04 seconds per millimeter times 21 millimeters equals 0.84 seconds per beat. So that's awesome, except for the fact that we do heart rate not in seconds per beat, but in beats per minute. So remember, there are 60 seconds in each minute. So in order to convert this, you would do 60 seconds per minute divided by 0.84 seconds per beat, and that will give you your heart rate, which is 71 beats per minute. So the overall formula, if you want to write it down, have it in your iPhone or something like that, is the rate is 60 divided by 0.04 times the number of millimeters between the QRS complexes. So if we want to wrap it up, why don't I get you to pause this video for a moment and calculate what the heart rate is based on the first sets of QRS on this ECG strip. And now if you're back from pause, that rate is about 88 beats per minute. Basically, you have 17 millimeters between the QRSs, and using our formula, that's going to give you 88 beats per minute. So that's it. Quick and dirty way to go for rate. So in summary, I actually just look at what the computer on the ECG machine calculates for my rate, and then I usually use the 300, 150, 100, 75, 60, 50 rule just to make sure that what the computer is calculating is about right. And that on a day-to-day basis is really how I do rate. And then if you really want to nerd out, I've given you the formulas here and the first principles to work it out if you're kind of one of those guys who've got calipers and a ruler and want to show how smart you are. So thanks for that, and we'll see you in the next lesson.